So in this presentation, I will be talking about colorization of a grayscale image using OpenCV. So for this experiment, we have used NumPy, which is used to work with arrays. We have used Matplotlib, which is used for visualization purpose. We have used CV2 library. So this is used to implement computer vision task. Here we have defined the path of the image, which we are going to work on in the further course. So using cv2 imread function, I am going to read the image, and in the img variable, it will get the image will get stored in the matrix format. So matrix is used to represent the image. So this function here perform the task of denoising the image. So you see, it uses non-local mean denoising algorithm for this purpose to perform image denoising. So the denoised image is stored in the DST variable, and now we have plotted the original and the denoised image. So you can see this is the original image that we have got, and this is the image after denoising. So the image is then scaled, the matrix is then scaled. Then we have converted uh, the BGR format of image into a lab format. So what does lab format means is, in the lab format we have the representation of image into three components. That is the lightness, where the in the first thing. Second, it represent the color component ranging from green to magenta. B represent the color component ranging from blue to yellow. Now then we have resized the image to 224 cross 224. Now you see, when we read an image, we convert the RGB into grayscale image, and again we do vice versa, like converting the grayscale image into an RGB image. We did not get the RGB image back. The grayscale image remains as it is. You can see the proof of that. So for the further experiment, we'll show how we can convert the grayscale image into an RGB format image. So again, we have scaled the image, then we have converted the RGB into a lab format. Then we have resized the image, and we have split the channel of image and considered the first channel to be worked on. Then we have implemented dense neural network using CV2, and for that purpose, we have read the already trained model weights for converting a grayscale image into an RGB format, and we have read the caffeine model as well. So we have points as well. Then we have built a architecture for converting a deep neural network architecture for converting grayscale image into an RGB format. So we resize the image later. Then we splitted the channels, and then we considered the first channel, and then we concatenated it. Then after colorizing, we got the result as this format. So this is representing the lab format. Then we converted that lab format into an RGB format of image, and we have clipped the image. Then we clipped the image between 0 to 1, and then we multiplied it with 255, which represent the pixel range ranging from 0 to 255. And here is the colorized image that we got. So you see, this was the grayscale image, and we converted that into an RGB format of image, and we have saved the output using CV2. Now the thing is how to calculate the accuracy. So basically, what does accuracy means is the closeness between the predicted value and the actual label. So in this case, we have two images, and we need to compare those two images and the similarity and the closeness between them, right? So for this purpose, there are different evaluation matrices that we have used. So we have used sever library for this purpose to calculate the evaluation matrices. So the you can find the full forms and details of the evaluation matrices that I have used through this website. So you see MSE represent mean square error, RMSE represent root mean square error. Similarly, you can find the full forms, and you can read further and get details of this parameters here using these provided links. So just we have read the image, we original and the predicted image. We have tried to we compared those using different evaluation matrices, and this is what the result that we have got.